All right, here's the start of 11.5. Remember, this is the section where we're going to take the previous 4 sections and combine it all into one. So it's really important that you're watching these videos, that you're pausing, you're replaying, you're practicing to making sure you really understand. Making sure that you do the homework, and not just until you get that green check mark, but doing similar examples until you fully understand. And then I even have some extra practice from 11.5 on Canvas that I highly suggest that you do to get a really good understanding of this section before moving on. Okay, we're going to do 3 examples. Here's example number 1. It says 6 jokes, one by Jimmy Fallon, Dane Cook, Larry the Cable Guy, Kevin Hart, Chris Rock, and Tina Fey are each written on one of 6 cards. The cards are placed in a hat and drawn one at a time. What is the probability that a man's joke will be delivered first and a woman's joke last? So the first thing I see is that keyword probability. And remember from the last section, probability, as soon as I see that word, I know that probability is what you want out of total. So that's how I'm going to organize myself. I know I need to figure out what we want out of the total number of options. It might be easiest to start with total first. So I have 6 cards, a joke on each card, and I want to figure out how I can draw these 6 names. So at this point, we've got to figure out if order matters or not. Is this a combination, permutation, or maybe it's just a fundamental counting principle? Well, I know that this is kind of the joke example that we have looked at in the past, where I could pick maybe Kevin Hart's joke first, or I could pick Chris Rock's joke first. And because I can pick a different joke and that would be a different outcome, to me, this is an example of a situation where order does matter. So to me, this is an example of a permutation. Ignoring the men, ignoring the women, just thinking about the 6 different cards in the hat. How many ways can I pick the 6 different cards? Well, because this is a permutation, I should be able to set up a permutation formula. I've got 6 total cards, and eventually I want to pick all 6 of them. Yes, I'm going to pick one at a time. But I have 6 total cards, and I'm going to pick all 6 of them eventually. And because order matters and could make a difference in the outcome, I know this is a permutation. Remember, we've used our calculator to use our permutation formula so we don't have to write out the whole kind of baby steps in between. So you should be able to use your calculator to do your 6p6, and you should get a total of 720. There are 720 ways you can pick out these 6 different cards from the hat. So that's our total. Now let's go back to what we want. Remember, we want the probability of a man's joke first and a woman's joke last. And so do you remember the bear example where we were picking bears to go to the different zoos and we wanted male bears and female bears? Well, this is the same type of idea. Because we have 2 different categories, specific things that are happening that are different, a man's joke and a woman's joke, we have to separate it into 2 different parts. We've got to think about the men part and we've got to think about the woman part, okay? So order still matters, right? A man can go first and be a different man depending on who you pick first. And so this is still a permutation. And so when I'm thinking about the men, how many different total men do we have? Well, we have 5 of them, right? And how many men are we going to eventually pick? Well, we're going to pick all 5 of them eventually. And then we have a woman. How many women do we have? Well, we have 1. Tina Fey is the only woman here. And we're going to pick her to go last. We have 1 woman, we're going to pick that 1 woman. And so I need to figure out what's the total number of ways I can pick this 1 woman and then pick these 5 men. We're going to pick men and women and put them all together. And so we're going to multiply those combinations, those different options together. And so using our calculator, I got 1 times 120, or 120 different ways we can pick the 5 men and the 1 woman. I have 120 want out of 720 total. If I reduce that, I get 1/6 or 0.17, or if they ask me as a percent, I can say there's a 17% chance that a man's joke will be delivered first and a woman's joke last. So you can think about permutations while you're doing this probability. I have another way of doing this example that you might like. I like this way too. So thinking about probability still, it's what I want out of total. And then I'm thinking there's 6 different spots, right? I'm going to start with the total first. If I was ignoring the specifics about men and women, but I knew that there were 6 people I could choose from, I need to pick eventually all 6 of them. So I'm thinking about there's 6 different lineups, right? When I go to pick the first person, how many people do I have to pick from? Well, I have 6, right? When I go to pick the next person, how many people do I have to pick from? 5, right? And we've done examples like this in the past when we were talking about permutations. Then I have 4, 3, 2, and 1, and I can figure out the total number of ways by multiplying all those together. You should still get that 720 like we did up above. But that might be a way to kind of visualize what's happening instead of just purely using those permutation formulas. Imagine the 6 different spots. How many total different ways can you pick the 6 people to stand up there? 6 times 5 times 4 times 3 times 2 times 1, 720 ways. A little more of a visual than last time. All right, but now we've got to figure out what we want. Remember the question says we want the probability that a man will go first and a woman will go last. I'm still imagining and visualizing the 6 spots, but I know in that first spot I need it to be a man, and I know in the last spot I need it to be a woman. So when I go to pick the man to be in that first spot, how many men do I have to pick from if I want a man to go first? Well, don't I have 5 men in the group? Now let's go back to the end. I need a woman to go last. If I need a woman to go last, how many options is that? How many women are there? Well, there's only 1 woman, right? And she has to go there, Tina Fey. So now let's go to pick the second spot. I've got to pick a person to go in this second spot right here. Now be careful. I've already put Tina in the back. I've already put a man in the front. So how many people do I have left? All right, I have 4, because remember Tina has to be in the back. There was 5 men left, but one of them was already picked to go first. So that means I have 4 men left. It has to be a man because Tina has to go last. Then I have 3, then I have 2, then I have 1. And I could figure out the total number of ways that could happen by multiplying them all together, and you should still get 120 just like we did up above. But again, I don't know about you, I like this way better than just purely using those permutation formulas because I can kind of visualize what's happening. I can imagine the 6 different spots. I can imagine a man going first and a woman going last and how many options I have for each spot. So you could do it this way or the permutation way. Either way, you should still get the same numbers, right? 120 out of 720, or a 17% probability. Keep practicing. You got homework problems that are similar. You've got that extra worksheet that are similar. We'll do a couple of different problems in the next few videos, but make sure you practice a problem that looks just like that one.